Greetings, physics fam. Today we're going to be looking at a whole bunch of different ideas using free body diagrams and also Newton's second law. We're going to apply a lot of different ideas, but something that we know about Newton's second law is that overall, if you have a net force, then you have acceleration in the same direction, and that is related to F net equals ma, as in F equals ma. Another thing to think about, what is overall net force? Another way to write net force is sigma F, right? So sigma F is the same thing as net force. Let's make sure we understand that. And then also, our net force is just going to be the sum of the forces. So if anything is up or to the right, we're going to say those forces are positive. Anything down or to the left, we're going to say those forces are negative. So let's just keep that in mind when we tackle all of this, and let's get going. Letter A here down below is a picture of an object that looks like it must be falling. How do I know that? Well, force of gravity is pulling it down, but there is air resistance pushing it up. So this object must be in the air. And if you look, the upward force is 0.1 newtons and the downward force is 0.1 newtons. So if we look at right here, sigma F, which is the net force, the net force is really going to be equal to a positive 0.1 newtons plus a downward 0.1 newtons, which is negative, right? This one would be negative because it's down. This one would be positive because it's up, which means when you add up positive and negative 1/10, it equals 0. So right away, we know that the net force is 0 newtons. Another thing we can say about this is that if it's 0 newtons net force, then we're in equilibrium. Now, if we look at our equation, if net force is 0, and no matter what the mass of the object is, it doesn't matter, acceleration is going to have to be 0, because if you don't have net force, you won't have acceleration. So we can assume that acceleration is going to be 0 meters per second squared. So the only thing left to do is figure out what is the mass of the object. Well, I know something about mass is related to the weight of the object, and since this object is falling through the air, we know that gravity is pulling on it. So let's look at this. Remember that the force of gravity is really the same as the weight of the object. So I can say that the weight of the object is 0.1 newtons. Since that's downward, I'm going to make that negative. The mass, I don't know what it is. I'm solving for that. And of course, gravity's acceleration on planet Earth is negative 9.8. So when I rock that out, I'm going to solve for m by dividing both sides by negative 9.8. And when I do that, we know that 9.8 will cancel out. I'll be left with m all alone. And then I'm going to take negative 0.1 divided by negative 9.8. And what I end up getting is 0.01 for my mass. So I'm going to put that in here, 0.01. Now, what are the units for mass? Well, mass units for this unit, or this area in our physics class, is going to be in kilograms. If you don't believe it, we could look at this equation, weight equals mass divided by gravity, or times gravity. Weight is in newtons. Mass is normally in kilograms. And gravity is acceleration, meters per second squared. So don't forget that a newton is the same thing as a kilogram meter per second squared. So when you divide over acceleration, and if you made newton the kilogram meter per second squared, the only thing that would be left that wouldn't cancel out would be the kilograms. So keep that in mind, mass is going to be in kilograms. All right, there's our first example. Let's go to letter B. As we take a look at letter B, goodness gracious, it looks like there's a force of gravity acting on the elephant, which is normal, but we have air resistance. So that means this elephant is falling through the air. Wow. Okay. This time you'll notice we have a different set of information. We already know the mass, and we already know the acceleration is 8 meters per second squared down, which for me means a negative. All right, so let me figure this out. I know for my net force is equal to mass times acceleration. Do I know mass and acceleration? Yes, I do. My mass is 10,000 kilograms, and my acceleration is negative 8.0. So I'm going to do this to solve for my net force. Now remember, sigma F is the same thing as F net. So you can use them interchangeably. Whatever you want to do for that one is fine. So now that we have this, let's multiply together. 10,000 times negative 8 is going to be negative 80,000. So for my overall net force, it's going to be negative 80,000 newtons. Wow. Okay. So now that we have that, that's a lot of force in the net force negative going down. A couple things to keep in mind. Remember, with Newton's second law, whatever direction net force is in, acceleration should be in. So notice how net force is negative and so is acceleration. They're both downwards. So just keep that in mind. All right, so now that we have that, how on earth can we figure out everything else? Well, I know the force of gravity is the same thing as weight. And I know my weight equation is mass times the acceleration of gravity. I already have my mass, and I know the acceleration of gravity, so I can solve for weight, which really is just solving for the force of gravity. So let's do that. Weight is equal to the mass, which is 10,000, times negative 9.8. When I do 10,000 times negative 9.8, I'm going to end up with negative 98,000 newtons. So that means my weight downward is negative 98,000 newtons. All right, so now that I have all this information, how am I going to figure out the air resistance? Well, keep in mind what net force means. Net force, or sigma F, however you want to look at it, is always the forces added up together. So that's going to be the force of air resistance plus the force of gravity. Now, I already know a couple pieces of information of that. Do I already know the net force? Yes, it's negative 80,000. Do I know the force of air resistance? No, but I want to, so maybe I'm going to solve for that. Do I know my force of gravity? Yes, I already solved for it. It's negative 98,000. So now if I solve for that, it looks like I have negative 80,000 is equal to something plus negative 98,000. So if I solve for that, really I just have to add 98,000 to both sides. 98,000 to both sides. When I do that, 98,000 plus a negative 80,000, what I end up with for my answer is a positive, I'll put a plus sign there, you don't need to, but I'll put a positive 18,000 newtons. So it looks like as this elephant has a huge amount of force of gravity pulling down negative 98,000, this object has an upward air resistance of 18,000 newtons. And when you subtract the two, it makes sense that you end up with a net force in the downward direction of 80,000 newtons. Now, really quick, what's happening with this elephant? Is it speeding up, slowing down, or falling at a constant velocity? Well, let's think about it. First of all, we know since it's falling, its velocity is downwards. And if you look at its acceleration is negative, so it's downwards as well. So if we know velocity and acceleration are downwards, we know then that we are speeding up, right? Because when velocity and acceleration are in the same direction, that means we are speeding up or our velocity is increasing. Wow, that was awesome. We took Newton's second law, knowledge of what weight is, and F equals ma, and what net force is, and we solved all those problems. Check out the relationships between everyone. This is outstanding. All right, let's go to the next one, letter C, and dive deeper. Checking out letter C, it looks like we have another object falling through the air. We've got air resistance acting against it, and of course the force of gravity pulling it down. If you take a look at what we're given a mass and acceleration already, and just so you know, acceleration is upwards, so that means I'm going to remember that my acceleration is positive 6 meters per second squared. Now, I already know how to solve for my net force. Remember, net force, which is the same as sigma F, is equal to, according to Newton's second law, F equals ma. So I can solve for my net force by simply plugging in my mass times acceleration, which is 800 times acceleration, which is a positive 6. When I do 800 times a positive 6, I end up getting about 4,800 newtons. So that means I'm going to put a plus sign here just to remind myself that this is in the positive direction. So I'm going to be 4,800 newtons. Once again, take note that acceleration is up and so is net force. Acceleration and net force are always in the same direction. That's Newton's second law. And now that we have all this information, can we finally figure out force of gravity and force of air resistance? And the answer is yes, we can. The next thing we have to do is remember that the force of gravity is the same as weight. So I know that weight is the force of gravity and that my weight equation is mass times the acceleration of gravity on planet Earth. So my weight is going to be equal to my mass, which we know is 800 kilograms, times negative 9.8 meters per second squared for the acceleration of gravity. And what I end up solving for is this is going to be about 800 times negative 9.8 is 7,840 newtons. So in the downward direction, I'm going to put a negative there just to remind myself that it's downward. But now I know my force of gravity. The only thing I have to do now is figure out what my air resistance is. And to do that, remember that my net force is always just all my forces added up. So it's going to be my force of air resistance plus the force of gravity. I'll put G for that. Now, my net force I already know. It's positive 4,800. My air resistance I do not know. I want to solve for that. So I'm going to leave that as some type of variable. And then last but not least, my force of gravity, remember, which is the same as weight, we solve for it, is a negative 7,840. If I do my math on that, since it's addition, I'm just going to add 7,840 to both sides. And that's going to cancel out, leave me with my force of air resistance. And when I do 4,800 plus 7,840, I end up getting about 12,640 newtons for my object. Now let's think about that. If my parachute, I'm falling through the air, but my upward air resistance is stronger than my force of gravity, am I still falling or am I starting to float upwards? Well, let's think about that. There's no way you would be floating upwards. You're still falling. So velocity is down, but your acceleration is positive, so it's up. So what does that mean? It means you're actually slowing down. That's why you have more force in the upward direction. Net force up means acceleration is up, and when acceleration is opposite of your movement, it just means you're slowing down or decelerating. So the whole time you still fall towards Earth when you skydive, even with the parachute open, but you're now just slowing down or decelerating because acceleration is working against you as you fall to the ground. If we jump to letter D, you'll see that there's not only forces now in the Y direction. Remember, up and down is the Y direction, left and right, horizontal, is the X direction. Just think of like a graph, X-axis and Y-axis. All right, so let's take a look at this. Overall, we know the up and down forces for gravity and normal force, so this must be a car that's on the ground. Those are equaled out. So there's no net force in the up and down Y direction. So I'm going to say that sigma Fy for the net force in the Y direction is equal to 0. But now I'm not worried about that y direction, I'm now worried about the x direction. If you look, the net force in the x direction, there's only one thing. That's 9,000 newtons from friction. So since 9,000 newtons is all that's there, that's the net force in the x direction. And since it's to the left, I'm going to say it's negative or backwards. Okay, so I have that information given to me. But now what? How do I find acceleration or mass? Well, F equals ma is an equation we can use, but I need m or a to solve for the other. So I don't think that equation is going to work just yet. However, I can figure out m because I know my force of gravity. Think about what equation allows me to solve for mass if I know force of gravity. Remember, my force of gravity is the same as my weight. So weight equals mass times the acceleration of gravity. Okay, so I can solve for my weight already. I know it's a downward force of 10,000 newtons. So my weight is in the negative direction, so it's down. Remember, weight is a force and force is a vector, so negatives and positives tell us the direction. I don't know my mass, I'm going to solve for that, but I do know gravity's acceleration is negative 9.8. To solve for mass, I can just divide both sides by negative 9.8. And when I do that, 10,000 divided by negative 9.8, I'm end up getting a mass of about 1,020.41. And my units for mass are going to be kg in kilograms, right? So let me fit that in there on my chart, 1,020.41, and that's going to be kg for kilograms. Now that I have that, I've got net force and mass. Can I solve for acceleration? You're darn right, we can. So my net force, this is in the x direction, that's what that little x stands for, the horizontal plane, equals ma. I know overall my net force is negative 9,000, that means to the left. My mass is 1,020.41, and my acceleration I don't know, but I can solve for that now that I have two of the three variables. So let me do that by just dividing out 1,020.41 to both sides, and you'll notice that my answer is going to end up being a negative value. That's good, because my overall net force is in the negative or left side direction, so should my acceleration, because Newton's second law says that net force and acceleration are always in the same direction. So I'm going to take negative 9,000 divided by 1,020.41, and what I end up getting is a number, let's see, put in my calculator, negative 8.82. And what are my units for acceleration? Meters per second squared. So my acceleration is going to be backwards as well. All right, so I've solved for that. Now I'm good. Let's think about what this really means. Well, the direction of the car has to be moving forward, right? Because friction is moving against it to the left, backwards. And if I look at my acceleration is negative, so that's backwards. So is this car speeding up or slowing down? It has to be slowing down. Why? Because it's decelerating. Velocity and acceleration are in opposite directions. Again, how did I know that? What direction it was traveling? Friction, always in this class, will oppose our motion. So if we're moving forward to the right, friction must be to the left. But look at that. We used a lot of different skills all in one to solve these problems. Pretty impressive and complex. Way to go with following along. But let's go through and finish up E and F as well. Jumping to letter E, we've got someone kicking a football. Not very smart, though. We're kicking it toes first. For my soccer players, I don't know if that's a wise decision. But let's see how it goes from here. So we already know the mass of the football is a half a kilogram. We also know that the overall total net force, rightwards, so that means the F net, the net force, and to the right, that's the X direction is the net force, all right, is positive 124. So first of all, I can solve for acceleration really quick because I know my net force is equal to mass times acceleration. My net force is a positive 124. My mass is 0.5 kilograms, and my acceleration, I don't know. but I can solve for that super quick. Let me divide both sides by 0.5. And when I do that, acceleration is 124 divided by 0.5, and that ends up being about 248. Remember, acceleration is meters per second squared. So 248 meters per second squared. Acceleration is forward, net force is forward, so that's good. Remember, net force and acceleration need to be in the same direction. Great. Now I've got all these guys taken care of. Now, let's figure out some of these forces. Yikes, we've got a lot going on. Good news is the force of gravity is the same as weight. And I know that weight is equal to mass times the acceleration of gravity. So my weight is equal to my mass, which is given to me 0.5 kilograms. Gravity's acceleration is negative 9.8. When I put that together, 1/2 times negative 9.8, I've got negative 4.9 newtons, which means negative is downwards. So here's my 4.9 newtons. I'm going to put a negative just to remind myself that it's downward. Now, take a look. If force of gravity equals out with normal force, that means that the net force in the y direction, that's the up and down, has to equal 0. So that means if it's 4.9 newtons going down, we can assume 4.9 newtons going up. They equal each other. That football's on the ground, so right, the normal force is just the equal but opposite direction of the weight or the force of gravity. Call it what you will. The only thing left then is, of course, my applied force. Yikes. Well, what's my applied force? Well, if you look, the total net force in the x direction is 124 newtons to the right. And it doesn't look like there's anything opposing the force. So if that's the case, then I think this is the normal force, or not the normal force, my apologies, the net force all by itself. So that means that this must be 124 newtons as well to the right, because this is the only force going to the right. There's nothing to cancel out. So it looks like we solved for everything. And it looks like we're going to be speeding up too. Looks like the net force is forward, acceleration is forward as well. I'm guessing this ball is going to get kicked forward and accelerate forward. So cool. Well, that was letter E. Let's move on to our last one, applying Newton's second law and getting down all these calculations and the relationships between mass, gravity, net force, normal force, total net force, X and Y. There's a lot going on. Okay, here is letter F. Let's take a look. This poor gentleman is pushing his car. Notice that the up force and the downward negative force cancel out. So there's no net force in the y direction. So sigma y equals 0. Cool. So we don't have to worry about that anymore. Awesome. Let's see. The applied force. Whoa. Looks like there's only one force moving forward. So it looks like the net force in the x direction and applied force are going to equal. We'll have to figure that out. So how can we figure this out? Well, I know the force of gravity is the same as weight. And I know that weight is equal to mass times the acceleration of gravity. So I can solve for mass that way. If I know the weight is downward 9,000 newtons, that's a negative 9,000. Mass I can leave as a variable to solve for. And gravity is negative 9.8. To solve that, I just need to get m by itself by dividing by negative 9.8 to both sides. Pow. M is now by itself. And when I do that, negative 9,000 divided by negative 9.8 ends up being about 918.4 kilograms. So let's go ahead and do that. 918.4 kilograms. Now that I have mass and acceleration, can I solve for net force? You betcha. The net force in the x direction, that's the horizontal plane, F equals ma. So let's solve for net force. My mass is 918.4 kilograms, and my acceleration given to me is 1.5. Multiply those two together, and my overall net force is going to be positive, it's not negative, positive 1,377.6. That's a force, so it's newtons. So it looks like 1,377.6 newtons. And take a look. The net force in the right direction, there's only one force. So it looks like this too is going to be 1,377.6 newtons. Awesome. There we go. Net force is positive with acceleration. Perfect. It has to be same direction. So we're good with that one. Now I made it sound like F was the last one, but we've got G and H. So let's tackle those two. G is quite lovely. It's an animal pulling a wagon. Isn't that wonderful? We've already got mass and we've got acceleration. So that means I can figure out net force because it looks like this is going to be in the X direction. It looks like up and down the Y net force, they should cancel out because it's just a wagon on the ground. So let's do it. Net force in the X direction is equal to the mass times acceleration. Let's see, mass is 15 kilograms. Acceleration is 0.50, 1/2. That's going to get me my net force. 15 times 1/2 ends up being 7.5 newtons is my net force in the X direction. So 7.5 newtons is there. And you guessed it, there's only one force going in the X direction, so this too must be 7.5 newtons. The only thing left to do is figure out force of gravity and normal force. Don't forget, force of gravity is the same as weight. And if I know my mass, I can figure that out. Let me switch colors and let's do that really quick. Weight is going to be mass times the acceleration of gravity. My mass is 15 kilograms. Acceleration of gravity is negative 9.8. So if I do 15 times a negative 9.8, it's going to be somewhere around 150, and it comes out to about negative 147 newtons. So what does that mean? It means downwards, which the arrow shows, so you don't technically have to write the negative, but downwards, the force of gravity is negative 147. Now we know that the upward and downward forces are going to equal out, so we can assume the normal force is 147 as well. All right? Love it. Newton's second law right there. Technically here too, this is just force equals mass times acceleration as well. We're just talking about a specific force we call weight and a specific acceleration we call gravity. Pretty cool, huh? Let's do one more and crush it. Letter H, feeling great. Let's look at this. Wow, we've got all the forces. We just need to figure out everything else. Goodness gracious. How do we do it? Okay, first of all, upward and downward forces cancel out. So first of all, the net force in the up and down Y direction equals 0. So that means the only thing left is the X direction. So the net force in the X direction is going to be backwards 100 newtons. So it looks like my net force is negative 100. All right. Let's see. I can't figure out acceleration yet because F equals ma. I'm going to need mass. Ooh, I can figure out mass though because mass is the same. Weight is the same as the force of gravity. And I know that weight is mass times the acceleration of gravity. So let me plug in. I don't have weight. Oh wait, I do have the weight. Perfect. Let me erase that. See, sometimes you got to work around a little bit. The weight is negative 600 newtons, right? It's downward 600. I don't have the mass, but I know acceleration of gravity is negative 9.8. If I want to solve that, I have to divide both sides by negative 9.8. Why? So I can get m all alone, just like me at freshman homecoming. And if we do that, negative 600 divided by negative 9.8, yikes, what do I get in my calculator if I figure that out? I get about 61.22 kilograms. So let me write that down, 61.22 kilograms when I put that in my calculator. Now that I have mass and the net force, can I solve for acceleration? Don't you lie to me. Of course you know. Yes. F equals ma. By the way, if you ever see a with a little x, that just means technically the acceleration on the x-axis. Just being more specific because there is an x and a y-axis, up and down, left and right. All right, let's see. Let's plug it in. I've got negative 100 newtons for my net force. I know my mass is 61.22, and I want to get my acceleration. So if I want to solve for that, I need to get ax by itself. Remember, the little x just stands for the x-axis, or left and right. Divide by 61.22 to each side, and a is going to be left alone. 100 divided by 61.22 ends up being, drum roll, negative 1.63 meters per second squared. Ooh, take a look. Negative 1.63, that negative is important. Why? Because the negative for net force and acceleration should always be the same. The direction of acceleration and net force should always be identical. All right, we did it. Nice job, crew. You followed through, you hung in there. Hopefully this is making a lot more sense, but man, a lot of layers to these problems. So keep crushing it. Proud of you. Ask questions in class. See ya.